So far in your mathematical career, you've only learned about graphing in 2 dimensions with an x and y axis. So we've looked at the Cartesian coordinate plane, where we have these two axes, and then when we graph something, we look at some distance left to right and some distance up to down. And that's how we graph points. But that's not the only way you can do it. Another way that you can do it is with something called polar coordinates, which you'll get into in pre-calculus. But we're going to do a little bit of setup for polar coordinates and exchanging between polar coordinates and Cartesian coordinates. So these are our circular coordinates, polar coordinates, and they use, instead of a left-right distance and an up-down distance, they use an angle and a radius. And so trigonometry is what allows us to relate one type of graphing to the other. So we're going to do a little bit of setup with this in 13.3 in terms of trying to relate xy coordinates to a radius and an angle. So if you look at this, we have the 0 degrees, 90 degrees, 180, and 270 going around this xy axis. And I have a circle there in standard position with the center of the circle at the origin. So let's see if we can find a way to, using trigonometry, relate r, theta, and x. We'll start with x. So let's look at a right triangle. So we can make a right triangle here, and then we can use right triangle trigonometry. So if I want to know the x value of this coordinate point, well, that's just the horizontal distance here. That's what x is. So using trigonometry, I could say the cosine of theta, that angle, is equal to the adjacent side x divided by r, which is the radius. Then if we take this and multiply both sides by r, we get that x is equal to the radius times the cosine of theta. So this is how we get x coordinates in terms of angle and radius. We can do the exact same thing for y. We can say that the sine, in this case, so the y value is the distance up. That's what y is. So the sine of theta is equal to y divided by r. Again, multiply both sides by r, and we get that y is equal to r sine theta. So x is the cosine, and y is the sine. So this will be very important when you get to pre-calc, so keep that in your head. We're now going to look at something called the unit circle. So unit means like 1. So we're looking at a circle. The unit circle is a circle with a radius of 1. And centered at 0, 0. So if we do the same thing as before, we can say that x is equal to r cosine theta. But if the radius is 1, then that's just 1 times the cosine of theta. So let's just write that as x equals the cosine of theta. We can do the same thing for y. And again, the radius is 1, so let's just write 1 times the sine of theta, which is just the sine of theta. So then we can use this to kind of map out what you will see in the future math classes referred to as the unit circle, which is this big thing on the bottom right. And so what we have here is this circle with a radius of 1, and we've mapped out all of the possible xy coordinates for these. If you'll notice, these are the same angles as the special right triangles. So we have 30-degree angles, 60-degree angles, and 45-degree angles, and then, of course, 0, 90, 180, and 270. So what these come from is from those special right triangles. So if we think about theta being, say, a 60-degree angle, then when we look at the x value, it's going to be the cosine of 60. And so if we do the cosine of 60, that's that value right there. It's 1/2. If we look at the sine of 60, that's the y value at this point. That's square root of 3 over 2. And so for all of these coordinate points, the x value is the cosine of that angle, and the y value is the sine of that angle. So if we look at, say, 210 degrees, the cosine of 210 is negative square root of 3 over 2, and the sine of 210 is negative 1/2. So then we can use this unit circle to start evaluating sine and cosine without having to use a calculator. And by the way, you'll see all this like pi over 6 and pi over 4 and 5 pi over 6 and all those things. That's something called radians, which you'll look at in pre-calc. We're not going to dive into that. If you're interested to know what that is, it's just another way of measuring angles. So if you're interested to know what that is, you're welcome to look in your book. It is in this section. We're just skipping over that part. So I'm not going to make you learn radians now. I'll leave that for Mrs. Stewart in pre-calculus. So let's look at the sine of 150. So 150 is right here. So that angle is what we're looking at. 150 degrees there. The sine of 150, that's going to be the y value. So that's 1/2. Let's look at the tangent of 60. So here's 60. Well, tangent is remember opposite over adjacent. Well, let's think about this for a second. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So if we take sine divided by cosine, that's going to be opposite over hypotenuse divided by adjacent over hypotenuse. And you guys learned how to take care of complex fractions like this. So one thing we can do is we could multiply by h over h, hypotenuse over hypotenuse, and that will leave us with opposite over adjacent. And so actually the tangent is really the same thing as the sine divided by the cosine. So if we're looking at the tangent of 60, well, that's going to be the sine, which is the y value, divided by the cosine, which is the x value. So we take square root of 3 over 2 divided by 1/2. And again, take care of this complex fraction. We could multiply top and bottom by 2. Then that cancels out, and we're just left with the square root of 3. Let's look at the sine of 0. So here is a 0-degree angle. The y value there is 0. That's the sine. The sine is the y value, and so the y value of 0-degree angle is 0. Let's look at the cosine of 0. So the cosine of 0 is the x value. That's 1. So cosine of 0 is 1. For a 90-degree angle, again, sine is the y value. Look at the y value there, that's 1. So the sine of 90 is 1. The cosine of 90 would be the x value, that's 0. So the cosine of 90 is 0.